Hello, everyone. I'm Emanuele Albini, and I will be presenting the paper explaining PageRank through argumentation. That it's a work that I've done together with Pietro Baroni, Antonio Rago, and Francesca Toni. I will start this presentation by briefly presenting how PageRank works. Then I will show how we transform PageRank into an argumentation semantics. And finally, I will show how this helped us generating better explanations for the output of PageRank. So PageRank is an algorithm that given web pages, consider them in a graph in which pages are the nodes of the graph and the links between them are the edges of the graph. And for the scope of this definition, we will call IU the parents of a page U and OV the children of a page V. And PageRank, the score that PageRank gives to a page is composed of two parts. The first part is due to users directly landing on a page that usually accounts for 15% of the users, while the second part is accounting for user visiting a page through a link from another one. And those are assumed to be 85% of the users. And in particular, PageRank consider a score of a page to be higher if the linking pages have a higher score, and the more outgoing links a page has, the less of its score will transfer to the children. So for example, in the image on the left, if we consider node theta5 that has only one outgoing link, it will transfer all of its 1.6 score to page gamma. While if we consider instead node alpha that has 3 outgoing links, it will not transfer to each of them 8.1, but only 2.7 each, that is 1/3 of its strength. So besides the formal definition, in other words, what PageRank does is that it models the web as a Markov chain in which the score of each page is the probability of finding ourselves on that page if we were randomly surfing the web. PageRank can be understood as a quantitative bipolar argumentation framework and a corresponding semantics. So first I will define what I mean by quantitative bipolar argumentation framework and semantic. A quantitative bipolar argumentation framework is a tuple in which we have arguments, we have relations of attacks between arguments, relations of supports between arguments, and a base score tau that is a function giving us a numeric value that tells us how solid an argument is independently from other arguments. Then, given a quantitative bipolar argumentation framework, we can also define a semantic for it, a gradual semantics, that is a function telling us the strength of every argument when put in relation to other arguments. And for example, in the image on the left, if we define the strength of an argument to be its base score plus the strength of its supporter minus the strength of its attackers, we get what is visualized in the slide, those values. This presentation I will also call with R plus alpha, the set of supporters of an argument alpha, and with the reversed plus alpha, the set of supported arguments by alpha, and the same for attacks. So PageRank, as I just described it, can be defined as a quantitative bipolar argumentation framework, as I said. And it's a framework in which the pages are the arguments of the framework. There are no attacks between the arguments, and the links are the support relationship between the arguments. The base score instead is the part of PageRank score due to users randomly landing on a page. And for this framework, we can define a gradual semantics that, beside its formal definition, what it does is that it assigns to each argument a score that is equivalent to the PageRank score of the corresponding page. This formulation has though some drawbacks, and specifically the semantics is non-monotonic. And what it means is that the strength of the support of an argument does not directly depend on the strength of supporters and attackers only, but also on, in this case, it depends also on the number of outgoing supports. So this gives rise to some counterintuitive results from a dialectical perspective, and we can see one in the example on the right, in which if we consider node beta that has two supporters, we have a first supporter with strength 0.13 and another one with strength 0.33. And if we consider node argument delta, it has again a supporter with strength 0.13 and 0.33, but it also has another supporter with strength 0.24. Now the problem is that delta has a lower strength than beta, even though delta has a stronger supporter set. So to solve this issue, we defined a PageRank meta-argumentation framework in which we do not put in the argumentation framework only pages, but also links. And the links are put in the argumentation framework in the form of meta-arguments, one per each link. And since each of the outgoing link of a page is competing to draw the strength of its parent, we put a tax relationship between all of them. This information was already in the PageRank argumentation framework, but was left implicit. And for this reason, the semantics defined on that framework wasn't having a monotonic behavior. So we can again define a semantics that is equivalent to the PageRank score of a page for the regular arguments corresponding to a page. And this semantics is defined depending only on attackers and supporters, and is defined in the same way for arguments and meta-arguments. This means that we get a monotonicity in this meta-argumentation framework. The new definition of PageRank as a semantics for a quantitative bipolar argumentation framework allows us to define several kinds of explanation for PageRank. And in particular, in this presentation, I will show 4 of them. The first one is what I call attribution explanation that answers the question, why a page has this score? Then we have a contrastive explanation that allow us to tell why the scores of 2 or more pages are different. Then we have additive counterfactual explanations that tell us which links could be added to increase the score of a page the most. And the Edit-sensibility counterfactual explanations that instead answer to the question, what is the impact of the addition of a link to a page with a link to another page. We tested this explanation on the web graph of Wikipedia that has around 1 million pages and 7 million links. And I will show you some examples of this while going through each of these explanations. While presenting this first kind of explanation, I will also show how using the meta-argumentation framework for PageRank allowed us to see certain interaction between links and pages that are otherwise difficult to be noticed from the raw output of PageRank. So in this figure, there is an example of the magnification of the basic PageRank argumentation framework that I defined before, that is directly derived from the output of PageRank. And we can see the argument Celtic people surrounded by its supporters with the sizes corresponding to the strength of these arguments. And if someone looked at this representation, they could think that Scottish people is the article contributing the most to the argument Celtic people. This is not actually the case, and instead it's Celtic music that is contributing the most to Celtic people. If we look, in fact, if we looked at the Meta-PageRank argumentation framework, in which there are also meta-arguments representing the links, we can see that the actual contribution of Scottish people is quite small when compared to the one of Celtic music. And the reason why this is happening is because Scottish people has a really high number of outgoing links that compete against each other, and therefore the actual score transferred, it's only a very small fraction. So with the meta-argumentation framework, we can describe what is happening in PageRank algorithm as a debate between pages and links in an argumentation framework. So to get to the first kind of explanation, the answer to the question, why is the score of a page such that, why is this the score of a page, is because of the score of its meta-argument that are the links linking to it. In our experiments, we have seen that usually 10 meta-arguments, so 10 links linking to a page, are enough to explain 96% of the score of a page. So this means that we don't have to generate a huge graph to explain the, for example, in this case, Celtic people, but it's enough to have only a few of the most important links to explain it. The second kind of explanation we generated is quite similar, but instead of showing the meta-arguments contributing to a single page, it compares the score of 2 pages, and it shows the common supporters into a single bubble where all the contributions are accumulated there. And this allows also potential users to appreciate some small contribution that otherwise could be ignored, because if we have all the supporters around each of these 2 bubbles for calorimeter and spectrophotometer, we would be limited in space to visualize all of them. But since we put all the shared one inside a single bubble, we can actually show only the different one. And this is something that happens quite often, actually. So in our experiments, usually 2 pages that are related between each other, so they have a link between each other, usually have around 42% of the supporters that are shared. So this is a problem that happen often. The third kind of explanations we define are additive counterfactual explanations. And in this explanation, what we are trying to answer is what are new links that we could add to a page that are not yet there to increase its score. So for example, if we have this attribution explanation for Aztec Empire, in which we see that there are some pages contributing to it, we want to know which are other links that could be added to Aztec Empire to increase the most its score. And here it's shown some of the possible in the graph are shown some of the possible links that could be added to increase the score. Of course, potentially we could add links from any page in the web graph, but this doesn't make too much sense, and this will make the number of candidates very high. So to limit this amount, we decided to put in these kind of explanations only pages, links to pages that have a hop distance of 2. And on average, these allow us to reduce the number of pages in this explanation from around 1 million, so the total number of pages, to 170 meta-arguments. The last type of explanations instead allow us to see how the score of a page is exposed to changes in other pages. So, for example, if we have this explanation, that is the explanation for rate mathematics, it's the attribution explanation for rate mathematics, and we have its supporter, we want to know what happened if we add a link not to rate itself, but to one of its supporters. And since the PageRank algorithm can change its output, even changing another page that is not mine, this is an important question to be asked. And in this last explanation, so we show which is the amount of score that rate mathematics would lose if another link was added to its supporter. And for example, in this case, we can see that if we add a link to ratio, a huge amount of rate mathematics score will be lost. And this amount can go up to 50% of the score of the page in our experiment, and usually it's not high, but still it's around 2.15%. And as soon as we change only one link, maybe the impact is limited. But if we start adding a lot of links from other pages to one of the supporters, we can reduce the score of a page of a very big amount. So to conclude, reinterpreting PageRank as a quantitative bipolar argumentation framework equipped with the gradual semantics does have some theoretical advantages, the satisfaction of monotonicity, but it also has some practical result in terms of explainability. And even if PageRank is an algorithm that might be considered white box, this kind of reinterpretation in an argumentative perspective allowed us to generate more compelling explanations for the algorithm. As future works, we could explore other kind of explanations for PageRank itself or its more complex variants that exist. Or another possible future work is exploring how other algorithms can be reinterpreted in an argumentative perspective to explain them better than what the raw output of them does. Thank you everyone for your attention, and if you have questions, I'm glad to answer.